You might think we live in a tranquil country, where the land we live in is nice and stable and has always looked the same. Nothing could be further from the truth. The beautiful country that surrounds us, the rugged coastline, the rolling green hills, the craggy mountains, were forged millions of years ago when Britain was a very different place. Giant geological forces have shaped the land we know today. And the evidence is hidden in the landscape right beneath our noses. It's an epic story of giant volcanoes, colliding continents, and of how Britain was ripped away from what is now North America. It's the story of the birth of Britain. Volcanic eruptions like these are some of the most terrifying and overpowering events on our planet. And I'm not just talking about choking the skies with ash and stopping air travel. I'm talking about colossal explosions, incinerating gas clouds, raining fire bombs, and unstoppable rivers of molten rock. These awesome forces of nature have shaped the world as we know it today. But you might think nothing like this would ever happen here. Volcanoes would never rear their heads in Britain. Well, you'd be wrong. I'm going on a 1,500-mile adventure to discover how volcanoes have shaped and built Britain, and how they've played a crucial role in sculpting some of our most glorious landscapes and historic cities. Be prepared to be blown away by our volcanic past. For my first evidence of volcanoes in Britain, I'm heading to the ancient city of Edinburgh. Edinburgh was home to one of the greatest scientific minds of all time. In the 1780s, James Hutton, a gifted medic and chemist, made an absolutely revolutionary discovery. Edinburgh had once been a gigantic volcano. Before Hutton, most people believed the rocks of Britain had been laid down in thin layers by a cataclysmic biblical flood 6,000 years ago. But Hutton was sure that had to be wrong. He was obsessed with rocks, and his detailed observations of how they formed would rewrite history and the way we see rocks forever. I'm on my way to Arthur's Seat, an 800-foot-high hill overlooking Edinburgh. I'm going to meet Dr. Catherine Goodenough, who wants to show me some evidence Hutton uncovered that led him to a surprising and controversial conclusion. On one of the coldest, most miserable days of the year, we're going to look at an area of Arthur's Seat that sparked Hutton's imagination. It's extraordinary, isn't it, that only a couple of hundred years ago, everybody thought that the Earth was just a few thousand years old.
Well, it was, exactly. I mean, they thought that all the rocks everywhere on the Earth had been laid down from ancient seas. They talked about Noah's flood and the fact that there would have been a sea covering almost the whole of the Earth, and then you could lay down the ancient rocks from those seas. And they thought every type of rock was laid down in that same way from those same ancient seas.
But Hutton found some rocks just round the corner here called basalt, and he was sure they hadn't been formed beneath an ancient sea.
This was the section that he really looked at, that he sketched in his notebooks. Because what we can see here, we've got these layers of sand and mud, essentially, and these what we call sedimentary rocks. And if you follow these layers along, and you can see that here, they stop, they're cut off.
The basalt's not only cut off, is it? It goes all the way round to the underside of the other rock. Wrapped around the horizontal layers of sedimentary rock is a loop of solid basalt.
So what did he conclude from that?
He concluded that these rocks, these sands and muds, must have been here first, and that then this basalt must have been forced into those layers.
In that single moment of genius, Hutton unlocked one of the greatest mysteries of the world. He'd heard about lava erupting in Italy, and he came up with a crazy idea. Could the same thing have happened in Scotland? He proposed that the inside of the Earth was so hot it turned rocks into liquid and then regurgitated them at the surface. This was how the basalt had cut through the layers of sedimentary rock. Hutton had correctly identified the telltale signs of an ancient volcano.
It's hard to imagine on a horrible rainy day like this, but that means that once Arthur's Seat, that towers over Edinburgh, must have been an active volcano blasting heat out everywhere. I wouldn't mind a very small active volcano here right now.
It was a truly astonishing revelation. Where cobbled streets and tenement buildings now lie, once a mass of molten lava flowed. But sadly, Hutton's revolutionary idea was largely ignored during his lifetime.
There was one really serious problem with Hutton's theories. His style of writing was so bad, no one had the faintest idea what he was talking about. And it was only after he died that people began to realise how significant he was.
Hutton's great gift was being able to imagine dynamic geological events that shaped our land millions of years ago.
What I find so extraordinary about this whole story is that by looking very carefully at the rocks and by using his razor-sharp mind, Hutton was able to paint a vivid picture of the distant past. He knew that millions of years ago, this whole area was under the sea, but that popping out above the surface of the water were vast, fire-breathing volcanoes.
Edinburgh's volcano was a monster, a giant that rose thousands of feet out of an ancient sea. Lava spewed and exploded from its main cone and side vents at 1,000 degrees Celsius. Edinburgh's massive volcano has long been extinct and has eroded away. All that remains is Arthur's Seat, the tough basalt plug which once fed the main throat of the giant volcano. But this volcanic beast didn't just leave its mark at Arthur's Seat. Remnants of it are scattered all over the city, including Edinburgh's most distinctive landmark.
The city boasts one of the most impressive and impregnable castles in Britain, but its success is due entirely to the local geology. Edinburgh Castle wouldn't really be a castle without Castle Rock.
Just like Arthur's Seat, Castle Rock is a massive basalt plug. All that remains of a side vent of Edinburgh's immense volcano. It's a castle builder's dream. Made from one of the hardest rocks in Britain, Castle Rock is a massive ready-made pillar, 250 feet high and 700 feet wide. Not even the most determined attack could undermine the foundations of this castle.
It's only when you get up close that you realise that the rock itself is an integral part of the castle. That's on the outside, but I'm about to get an exclusive view of the inside to see how the foundations were made.
Most of the top of Castle Rock has been obscured from view, as castle after castle has been built above it. Historian Peter Yeoman believes this rock literally is the bedrock of Scottish power. He's agreed to take me down a secret passage to take a look into the bowels of Edinburgh Castle.
So this shaft was undiscovered for centuries.
That's right. This existed here, but it was filled up, and it was only rediscovered at the beginning of the 20th century.
What's this massive wall behind you?
This is part of the face of David's Tower. We'd have been standing in the open air 600 years ago, and this is the great mass of the side of this tower house.
But this is natural rock below it, isn't it?
That's right. This gives you a very clear idea of what so much of the craggy summit at the top of the castle rock here would have looked like.
So it's like a big historical secret, isn't it? You've got all the power and glamour and prestige of the massive castle up there, and it's supported by this huge outcrop of natural rock, and no one's really aware of it.
That's right. This was the seat of royal government, and if you held Edinburgh Castle here, towering over the city of Edinburgh and the Forth, you held the heartland of the medieval kingdom.
So this vast lump of rock has played a pivotal part in Scotland's history. So maybe it's not surprising that in many ways Edinburgh was the birthplace of geology.
But Hutton didn't just figure out how Edinburgh was made, he was beginning to understand how the whole planet was created. He realised that whether rocks were formed from molten lava or deposited by ancient seas, it wouldn't take thousands of years to make them, but probably millions. In a flash of brilliance, he realised the Earth was very, very old indeed.
Hutton was a really colourful character, although you won't find any little blue plaques dedicated to him around here, because legend has it that whenever he came to Edinburgh, he stayed in his favourite brothel. Nevertheless, some people say he was one of the top 4 or 5 scientists ever, the Stephen Hawking of his time, although it wasn't the age of the universe that Hutton was interested in, but the age of our planet Earth.
Hutton's fascination with the age of the Earth opened the door for future generations of scientists to figure out our entire geological history. I've spent a large part of my life digging for clues that are a few thousand years old. But this story begins hundreds of millions of years ago, when the Britain we know today was once scattered across the globe like pieces of an unmade jigsaw puzzle. I'm going to explore how huge volcanoes have played a key role in bringing those far-flung pieces together. The first step in the birth of Britain. Dotted across Britain, hidden right beneath our noses, are the remnants of our violent volcanic past.
Geologists will tell you that volcanoes are key to understanding how the world works, and I want to see how relevant that is to the creation of our small islands.
I've left the ancient and historic volcano in Edinburgh, and I'm heading to Snowdonia, Wales. Rolling back the clock millions of years to find evidence of some of Britain's oldest volcanoes, the key to understanding the very birth of Britain. Snowdonia is one of Britain's most breathtaking and serene landscapes. And for me, the only way to see it in its full glory is from the air. But don't be fooled by its lush pastures and rolling hills. This is a volcanic graveyard, the site of one of the most ferocious battles Britain has ever seen. A battle that would start to build the Britain we know today.
You know what this reminds me of? You know, if you visit a World War I site now, and it's beautiful and calm and covered with grass, and you can hardly believe that all the carnage took place there. Well, that's what this is like. It's stunningly beautiful. It's almost impossible to remember that at one time, right here would have been virtual Armageddon. From this central vent all the way to Mount Snowdon, which is about 10 kilometres, this whole area would have been covered in ash and volcanic rock. Wouldn't have been a great place back then, but now, well, you can see for yourselves, can't you? 450 million years ago, at the same time that Snowdonia was ablaze with volcanoes, the countries which now make up Britain lay on different sides of an ocean. The lands that would become England and Wales were part of a strange southern continent, and hundreds of kilometres to the north across an ancient ocean, the lands that would become Scotland and Ireland also lay buried within the body of a massive continent. Hazel Pritchard, a geologist from the University of Cardiff, is going to show me how Britain finally pulled itself together. Come on, Hazel. She's taking me on a volcano hunting expedition and is going to recreate this epic battle scene. As I suspected, it involves a trek up a pretty big mountain. You been up here before?
Yes, several times. There are some clues to what the environment was like here 450 million years ago.
You sure you know which way you're going?
Yeah, it's not far now.
To the untrained eye like mine, this mountain is scattered with a random collection of rocks. But to Hazel, their precise location on this huge mountainside reveals a fascinating story. Let's just hope she remembered to pop a compass in that handbag of hers.
This is what I really want to show you.
Yeah.
It's just up here. You come around here. You can see it from there.
But is it this?
Yes, this thing here.
That's bizarre. It looks like it's been squeezed out of a tube.
Well, it sort of was. It's a fossilised pillow lava.
Pillow lava?
This is a bit like what's happening in Hawaii today, where you can see pillows forming under the sea around the coast.
So the plot thickens. Hundreds of millions of years ago, I'd have been swimming in coastal waters with lava exploding under the water. As it cooled, it would have cracked and crackled like gunfire, forming strange pillow-shaped rocks. Hazel assures me that further uphill is rather more dramatic evidence of the immense volcanic battle that took place here so long ago.
This is something I really wanted to show you. Just here.
This rock
Yes.
looks like it's been rather badly pebble dashed, doesn't it?
Well, it's nature's pebble dash. Those are the pebbles, and you can see they're really stuck in the rock.
Oh, yes, they are, aren't they? Absolutely solid.
And they're volcanic bombs. They've exploded from the centre of a volcano.
Where would it all have been coming from?
It would have been coming from the vent, which is up there.
Oh, yeah. It's quite awesome, isn't it, being under that?
So hundreds of millions of years ago, we'd have been standing on the side of an explosive volcano rising out of the ocean. As it erupted, it would have blasted thick, sticky grenades of molten lava high into the air. And as they fell, they'd have rained down on the rocks below like shrapnel.
How big was this volcano, Hazel?
Oh, this was a mega volcano.
How do you know that?
Huge volumes of ash. We're standing on them here, and they're filling the whole hillside over there.
Where?
Over there, you see the striped rocks and then the whole of the hillside as you go up.
Why is it stripy like that?
The stripes represent different eruptions. These were pyroclastic flows.
Pyroclastic flows are the deadliest weapons in a volcano's arsenal. If Hazel and I had been standing here millions of years ago when this beast blew, we'd have been engulfed by a lethal avalanche of burning gas and boulders racing towards us at over 100 miles an hour.
This really is quite an extraordinary place, because I know it's pretty difficult to imagine on a lovely spring day in the 21st century, but 450 million years ago, this whole area would have been awash with a tropical sea teeming with life, and sticking out of the water there would have been these vast mega volcanoes spewing lava bombs and ash high into the air. It would have been fairly spectacular. But why were they all here? The sheer size of these ash flows, covering huge areas in Snowdonia, reveal the true force of this volcano. It was over 100 times more powerful than Krakatoa. Imagine that ricocheting across the Welsh countryside. And there wasn't just the one terrifying volcano here. There was a whole chain of them aligned along the northern coast of an ancient continent. The massive continent which contained the lands that would become England and Wales. This ancient continent was pushing northwards. As it did so, it gobbled up the ocean floor, which then remelted and was regurgitated as massive volcanoes along the coast. And that's only half the story. Hundreds of miles to the north, exactly the same thing was happening on an ancient continent containing Scotland and Ireland. And this continent was heading southwards. The land masses were on a collision course, gobbling up the ocean in between. Until finally England and Wales crashed into Scotland and Ireland. The volcanic battle zone left behind isn't just found here in Snowdonia. It extended north, creating some of our most beautiful and iconic landscapes. The Lake District, 500 square miles of ash and lava, in places over 3 miles deep. And 400 miles further north in Scotland, Glencoe, once a colossal supervolcano, which spectacularly erupted, blasting out thousands of cubic miles of magma. Like an enormous wound, this gigantic volcanic strip binds together the two halves of our nation. Finally, all the bits of Britain came together. The land that would become Wales and England crashed with what's now Ireland and Scotland. It was a pretty slow 3 inches a year kind of crash, but nevertheless it was a very important one, because if it hadn't been for the movement of those tectonic plates, the present-day journey from Land's End to John O'Groats would be a really long one.
But there's a problem with geology. Nothing stands still for long. No sooner had the pieces of Britain been fitted together than it began to pull apart. And once again, gigantic volcanic forces were at the heart of the action. So far, in my quest to explore ancient volcanoes in Britain, I've discovered that the separate parts of England, Scotland, Ireland and Wales were brought together in volcanic mayhem, when two massive continents collided, forming a huge supercontinent. But Britain was stuck right in the middle of it, and so was the North American continent. The next stage of my investigation is to understand how Britain wrenched itself free to shape the islands we know today. And I'm keen to understand what role volcanoes played in its dramatic past. To find out, I'm heading north to one of our most iconic landmarks.
We're about to witness a titanic struggle as the rocks of Britain try to break free from the rocks that make up North America. And the evidence of this battle, suitably enough, can be found right here, underneath Hadrian's Wall.
I bet almost every school child will tell you that the Roman Emperor Hadrian built a vast wall across northern England to keep the Scots at bay. Well, that's really less than half the story. Hadrian's Wall extends west from Wall's End on the River Tyne to the shores of the Solway Firth. A distance of 80 Roman miles. That's 73.5 modern miles in total. But what amazes me is that although this was the biggest defensive structure in Roman times, it took only 6 years to complete. And that's because there's something rather special about the wall's construction and location.
I've been up here to Hadrian's Wall lots of times because of the Roman history and the archaeology. But to understand why it's here, you need to see what it was built on, and that means looking at the geology.
The Romans were canny engineers. They deliberately made the wall follow the path of a vast half-buried slab of volcanic rock called the Windsill.
Hadrian's Wall is way up above me. Over there is Scotland, so when the Scots, or the Picts as they were known then, were attacking here, the first thing they would have seen wouldn't have been Hadrian's Wall, it would have been this.
To get an idea of the size of Windsill, once again I'm going to hitch a ride in a chopper and see it from the air.
It's only when you get up here that you realise quite how extensive the sill is. Not only that, but you can see the shape of it too. It really does look like a sill, doesn't it? A windowsill. It's really chunky, sticking out in the landscape. It's a massive geological feature. This is just the leading edge of it, but it goes back in that direction under the Northumbrian countryside for mile after mile.
This vast 20-metre high cliff stretches right across the neck of Britain and even extends beneath the North Sea. So how was this gigantic slab of volcanic rock created? And what part did it play in the birth of Britain? Nick Petford from the University of Northampton has come to reveal all.
Nick, what's this great cliff face made of?
Well, to answer the question, it's good to get a fresh piece of the material so I can look at it in a bit more detail. And with a hand lens, if I look closely, in fact, even with the naked eye, I can clearly make out tiny crystals. If you have a look, you can perhaps see some of those white flecks.
Yeah.
So they're crystals, and that tells me that the rock has cooled down relatively slowly. That means that the crystals have had time to grow slightly larger. So that tells me that this particular magma didn't reach the surface. It intruded at some level beneath the Earth, a few hundred metres perhaps. As the magma comes in, it's, if you like, shielded or lagged by the rocks above it. Therefore, it takes a bit longer to cool down. It's a bit like kind of lagging around your boiler. You know, this magma's been lagged by the rocks above it, cooled a bit more slowly, and it's slightly coarser grain than you'd get if it erupted straight at the surface.
So this entire cliff was once a red-hot layer, insulated and trapped by hundreds of feet of rock above it.
Why did the magma come up in this great slab rather than shooting up through the surface as a volcano or a series of volcanoes?
What happened about 400 million years ago is that these two colliding land masses came together and formed a line which runs up from Wales up through the Lake District and up through the southern part of Scotland, kind of wide boundary like this. After this collision had happened, something strange began, and that is that the crust to the south of this line, this suture line, started to stretch apart, pull apart in this area. An analogy would be sort of stretching pizza dough. As you sort of stretch it, it gets thinner. And as the stretching continued, magma from very deep down in the earth starts to move towards the surface, but it doesn't break the surface and make a volcanic eruption. Instead, it shoulders apart the horizontal layers of rock and spreads out laterally or sideways to produce finally, as it crystallizes, a vast slab of rock.
300 million years ago, the land beneath me was stretching and thinning. A gigantic tongue of molten rock, almost 17 trillion cubic feet in size, surged upwards, but it never quite broke the surface. No volcano exploded here. Instead, the magma barged its way between the buried rock layers, exploiting this line of weakness. It travelled right across the neck of Britain, laying down a giant 150-foot thick, 50-mile wide and 75-mile long slab of hardened magma beneath the Earth. And luckily for the Romans, the layers of weak rock above it eroded down, exposing the 70-foot vertical cliff of Wind Sill.
I always thought that it was Hadrian's Wall that stopped the Picts invading from the north, but as you can see on its own, it's really quite puny. What was just as important was clearly that great lump of magma. And it's not just here. It's over there, over there, over there. It stretches away as far as the eye can see. But the stretching that created this enormous volcanic slab stopped after just a few million years, and Britain remained attached to what's now North America. Eventually, though, a split did occur, and Britain broke away to become the small islands we know today. But the events of this final battle didn't play out here. They happened on the dramatic western coast of Scotland 240 million years later. And that's what I'm going to explore on the next leg of my journey, looking at some of Britain's youngest and most humongous volcanoes. Whew. At last, after what's been a very long journey, I've finally come to the last chapter of our story. 60 million years ago, Scotland and the rest of Britain were firmly joined to what's now the North American continent. But today, America is 2,000 miles in that direction. To find out how that happened, I've come to the scene of the crime, here to the exquisitely beautiful, if slightly damp, island of Skye. Well, it's a bright and early start, and I've met up with volcanologist Dougal Jerram on the Isle of Skye.
Around you can see are all made of this igneous rock.
He's going to help me understand how Britain moved 2,000 miles away from the American continent. Skye is a volcano fanatic's dream. On its eastern coast lies the remains of one of the largest and most spectacular volcanoes in Britain, the Black Coolins. These dramatic peaks formed 60 million years ago, at the same time that Britain made its break from North America. Well, after an hour's ride across Loch Scavaig, we're finally nearing our destination.
Well, now we've sort of officially landed in the centre of a volcano. Let's go and have a look at some of the marvels that we can see in the rock layers inside.
I'm keen to know just exactly how big this volcano was. I must admit, I was expecting to see a massive cone-shaped volcano towering above us like Mount Fuji in Japan. Dougal assures me it'll all become clear.
So where would the top of the volcano have been?
Well, millions and millions of years ago, if you can imagine where we're stood today, we're right in the sort of bowels of this system. Probably 1 to 2, maybe even 3 kilometres above us, there was a volcanic vent sort of pumping out lavas and explosions to the surface.
So when you say we're in the inside, is that the magma chamber where the lava was cooking up to eventually be spewed out?
Yeah, it's almost like the cauldron of the magma, where the magma comes into the shallow surface of the Earth, blisters up before it erupts at the surface. That's what we call the magma chamber, or the magma chamber plumbing system.
60 million years ago, we'd have been standing inside the magma chamber at the heart of this colossal volcano. Its scale is almost unimaginable, 12 miles across. From this central reservoir, magma rose to the surface, creating a gargantuan volcano over 2 miles high and 15 miles long. Over millions of years, this immense volcano has been eroded away, and all that's left is its carcass, the black coolins, the exposed shell of its vast magma chamber.
How hot would it have been right here when the volcano was at its height?
When we see the same composition rock types erupting at volcanoes in Hawaii and Iceland, these can be 1,100, 1,200 degrees centigrade, so 4 or 5 times hotter than the hottest temperature you can get in your oven cooker at home.
So a bit warmer than today then.
On a freezing day like this, you can hardly imagine an immense volcano erupting here.
This volcano was erupting at the time when Britain was wrenched away from what's now North America. But what extraordinary force created that volcano and caused a whole continent to be ripped apart?
My exploration of the volcanoes of Britain has finally brought me to the island of Skye, home to one of our biggest ancient volcanoes. And it was erupting at the same time that Britain made its break away from America. What's even more puzzling is that this fiery beast wasn't just big, it was one of the most prolific volcanoes on the planet. I've seen the guts of this massive volcano. Dougal's now hiking me 15 miles down the road to take a look at the outer edge of this monster and its unimaginably vast lava field.
Certainly picked up a bit. Well, the reason for dragging you this far, Tony, is to come to see this fantastic bay in the island known as Talisker Bay. And here she is, Talisker Bay, and all of these cliffs you can see all around us. All the rocks up here, the crags in Talisker Bay, all of these rocks behind, along, even those big cliffs up in the background. This is all lava.
All of these mountains?
All of these mountains, yeah. They're sheet upon sheet of basaltic lava flow.
What, even that great lump of a mountain up there?
Yeah, I mean, that's Preshel Moor. That's actually been fingerprinted, almost like a DNA print, back to the big volcano that we were in this morning.
That's a huge amount of lava.
Yeah, kilometres away from here, travelling to this distance.
I wouldn't have liked to have been around here when that was kicking off.
All this lava from just one single volcano. The island is like one massive lava field. Mile after mile after mile of volcanic rocks, hundreds, sometimes thousands of feet deep. The Black Coolins volcano spewed out thousands of cubic miles of lava. It was like an unstoppable tap of molten rock. It may have been one of the biggest volcanoes, but it wasn't alone. There were dozens more lava-producing vents here 60 million years ago. So why did Skye's volcanoes produce so much lava? And what's this telling us about how Britain was ripped away from North America? Dougal tells me a clue lies in the lava itself.
And here we go. Here's a lovely example just here.
That's extraordinary. It looks like a great wet cow pat.
Well, yeah, in some ways it does. What you've got here are sort of a series of ripples that they're almost like ropes that form. And this texture's called a ropey lava or Pahoehoe lava flow.
How old is it?
Well, this particular flow is around about 58, 60 million years ago. So actually looking at the fossilised top surface of a lava. And it's only really sort of visible here because of the way the waves have actually eroded this top surface. It's almost revealed from removing tons and tons of lava above here. This snapshot in time, we're able to see this. This could probably erode away in a few hundred years' time.
Millions of years ago, we would have been standing in a river of runny lava. As it cooled, the outer crust hardened, but the inner molten rock continued to lurch forward, creating rope-like lobes and building up in layer after layer over thousands of years.
What does it tell us about the birth of Britain?
Well, I think if you put the pieces together, it's quite special. We've got this ropey Pahoe lava. That only occurs when we have hot, runny lavas. We find these in Iceland today. And when we get hot upwellings of this really sort of low viscosity runny lava, that happens when continents start to split apart. So here we're actually seeing a snapshot of, in effect, the smoking gun of a process that's happening around about 60 million years ago, the very point where we started rifting and drifting away from the American continent.
60 million years ago, Britain lay trapped between the American and European continents. But then this massive continent began to split apart again, when a huge current of molten rock surged upwards from deep inside the Earth. It hemorrhaged millions of tons of runny lava at the surface, creating the volcanic mountains of Skye. All along the rift, this rising molten rock also spread sideways, creating new sea floor and forcing the giant plates of the Earth apart. It pushed the American plate to the west and the European plate and Britain to the east. And the North Atlantic formed in between, creating the distinctive coastline of the British Isles. Over 60 million years, this process has pushed Britain 2,000 miles away from America.
The enormous heat deep inside our planet continues to power this process, and as a result we're still moving away from America at the rate of around about 3 inches a year, which is about the time it takes to grow your fingernails. And for exactly the same reason, there are still highly active volcanoes erupting today, not here, but hundreds and hundreds of miles away over there in Iceland.
Iceland now sits above the very same crack in the Earth where Skye once sat. These eruptions, which today create new mountains in Iceland, are the direct descendants of the volcanoes that once built Skye and drove the continents apart. When the Earth splits open here, it does so along terrifying mile-long tears in the ground, which ooze millions of tons of lava in a matter of minutes. This awesome spectacle is how the Isle of Skye must have looked 60 million years ago, before its volcanoes were extinguished forever. This volcanic process was so massive, it not only created Skye, but also the magical islands of the Hebrides, and some of the most precious volcanic wonders in the world, including Northern Ireland's legendary Giant's Causeway. Ancient volcanoes have built our land and even today continue to shape our lives. Since James Hutton first discovered a volcano in Edinburgh, hundreds of remnants of our volcanic past have been found, scattered across our landscape and embedded in our history. They tell an amazing story of how the jigsaw pieces of Britain collided together and how they pulled themselves apart again to become the islands we know today.
The history of the birth of Britain is an incredible story. James Hutton, the father of geology, figured out not only that Britain was very old, but also that once it had been dotted with volcanoes in the distant past. And we now know that those volcanoes were part of the process that smashed continents together and pulled them apart to create the Britain we know today. For me, it's been an incredible journey. I've come to realise that the Earth we live on is almost alive. It's a dynamic planet, one that never rests.